I'm Kerryn Hart, and I'll be talking about how conceptual modelling can be used to understand the interconnectedness of a system for building its resilience. I'll be demonstrating how conceptual modelling can be used to build resilience with some abstract examples, as well as some real-world examples from forestry and rangelands. In this context, a system is a socio-ecological system that provides ecosystem services to people. This type of system is a complex adaptive system because of the diverse interconnected components that interact, adapt and evolve along unpredictable, nonlinear pathways. The resilience principle number 4, foster complex adaptive system thinking, includes adopting a systems framework with systems thinking, understanding thresholds, drivers, controlling variables, feedbacks, and adaptive cycles, then application in the real world. Part of systems thinking is understanding the interconnectedness of a system. Systems thinking is a form of mental model or cognitive framework that recognizes complex adaptive systems and emphasizes holistic, integrated management approaches so that management actions build system resilience. Rather than conventional management approaches, systems thinking includes uncertainty, experimentation, and adaptive management of uncertainty, disturbance, shocks, and surprises. In this way, systems thinking affects the choice of management approaches which may help to build a system's resilience. Thresholds affecting the resilience of a system are demonstrated with a ball and cup conceptual model, where a ball represents the current system state and the basin of attraction represents a potential system state. A perturbation or disturbance may cause the ball to cross the threshold of the basin and shift the system to an alternate state. Drivers are external forces on the system, such as vegetation clearing. These disturbances drive change in levels of controlling variables, such as groundwater depth, and can push the system over a threshold or tipping point like 2 meters below surface level to a state regime shift such as salinized soil. Monitoring programs are based on measuring indicators that are sensitive to changes in controlling variables. A conceptual model of a system can help managers identify and select appropriate ecosystem function indicators to monitor drivers of impending system regime shift or monitor management intervention outcomes. System state is governed by feedbacks between controlling variables. A causal loop diagram is a conceptual model of feedbacks in a focal system, and development includes engagement with interdisciplinary experts and stakeholders, which facilitates mutual understanding of the interconnected system dynamics. Systems are dynamic and continually changing, and this can be represented in the adaptive cycle, which is a conceptual model of change. The front loop represents the slow stages of exploitation and conservation, while the back loop shows the rapid stages of release and reorganisation. The panicky conceptual model illustrates linkages of nested adaptive cycles interacting over temporal and spatial scales. The focal system responds to constraints from larger scale systems and innovations from smaller scale systems, so identifying the cycle phase can expose vulnerabilities or opportunities. There are 3 properties of the adaptive cycle: potential, connectedness, and resilience. Potential is the amount of wealth or energy resources accumulated in the system, and this is an influence on the possible future alternate system states. Connectedness is the degree that a system's controlling variables are connected. It affects the flexibility or rigidity of internal controlling variables to external disturbances and becomes more rigid and vulnerable with more connectedness in the late conservation phase of the adaptive cycle. Resilience is defined as the capacity of a system to absorb disturbance while retaining its function and structure to provide desired ecosystem services. Resilience is inversely proportional to connectedness, so may be improved using interventions to manipulate connectedness. Conceptual modelling is the process of developing a graphical model of a system. It fosters systems thinking by helping stakeholders develop a common mental model in their understanding of a system's dynamics. This helps with problem solving and adaptive capacity to build resilience. Conceptual models are the product of conceptual modelling and can help to simplify an issue, understand the interconnectedness of a system, and identify management actions. Conceptual models can visually represent system interactions, drivers, values, processes, threats, thresholds, and regime shifts. As resilience is dependent on a system retaining its structure and function, this causal loop diagram example identifies positive feedbacks for abiotic and biotic structural and functional change processes in rangeland degradation from exotic grasses and identifies management intervention points. This conceptual model example helped build resilience within a degraded forest system. It shows the effect of management actions that manipulated species composition to influence forest development, which modified the system's resilience and connectedness to reshape the system's basin of attraction to a desired state. The Resilience Alliance workbook helps develop a conceptual model of a focal system. This example reveals the interconnected dynamics of a system, external processes influencing slow-changing variables and fast-changing variables, and the resulting institutional responses. In summary, conceptual modelling can be used as a tool to shift mental models to systems thinking, to understand the dynamic system interconnectedness. This enables appropriate management actions and increases adaptive capacity for building system resilience for sustainable provision of ecosystem services.